Hello, precious one. I welcome you once again to Kenya Mathematics Classroom. On this particular episode, we are going to look at the continuation of sequence and series, and we are looking at the nth term of a linear sequence. That was what we were looking at in our previous episode. Now, there is something I'm going to show you. You know for now that the nth term of a linear sequence is given by un equals a plus n minus 1 times d. And now you know the terms. The n is the number of terms, a is the first term, and d is the common difference. And you know how to find the common difference. You know how to get your first term. That's the first element, the first term of the sequence. Now there is something I'm going to show you, that this un equals a plus n minus 1 times d can also be equated to L. Can also be equated to L. Now, you know that the n is the number of terms, a is the first term, then d is the common difference. Now the new term here is L, and the L is the last term. Is the last term. That means that when the last term of the sequence is known, you can find the number of terms. Let's take a look at this example. Let's assume that we have to find the number of terms of the sequence. We have to find the number of terms of the sequence. We have 4, 2, 4, 6, we have 8, up to 20. Now, you can see that this is a finite sequence because the last term is known. So, assuming that you have to find the number of terms of this sequence, how do you do that? Now, you know that un equals a plus n minus 1 times the common difference, and this is equal to L. That's the last term. From the sequence, the first term is 2. You know how to find the common difference. That is the second element minus the first element. That is 4 minus 2, and the answer is 2. Or the third minus the second, that is 6 minus 4 is still 2, or 8 minus 6 is still 2. So this is a linear sequence or an arithmetic progression because it has the same common difference. And you can see now we are also given the last term to be 20. The last term is 20. And we have to find the number of terms of this sequence. So the n is now our question mark. So if un equals a plus n minus 1 times d, and this is equal to L, then we can say that a plus n minus 1 times d is equal to L without this, because you know that if you have x equals y is equal to 2, this means that x equals 2, then y is also equal to 2. That's the meaning. And so if you have un equals a plus n minus 1 times d equals L, then it means you can equate this to that. It's the same thing. That's what I'm showing you here. Now, our first term from the question is 2. The n is not known, so we have n minus 1, but the common difference is known. Common difference is 2. And the last term of the sequence, the last term has been given to be 20. So we have 20 here. Now we simplify. We have 2 plus 2 times n will give us 2n. Then 2 times minus 1 will give us minus 2, and this is equal to 20. Now 2 minus 2 will give us 0. So we have 2n on the left-hand side is equal to 20. Don't forget that we are looking for the number of terms, that is n. And so in finding for n, we divide both sides by the constant attached to that variable. So we divide through by 2, we divide through by 2, this is gone, and n is equal to 2 into 20 is 10. So the number of terms of this particular sequence is 10. Now you can see, let me show you this. Now that you know that the common difference is 2. When you add 2 to 8, you are getting 10. When you add 2, you are getting 12. 2, you are getting 14. Another 2, you are getting 16. Another 2, you are getting 18. Another 2, then you are here. Now you can count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why you are getting the 10. That's all. That's the 10 you are getting here. But you don't need to do this. And that is why the formula is there. So when you know your first term, the common difference, and the last term is known, you can use this formula to find the number of terms. You can use this formula to find the number of terms. So take note that un equals a plus n minus 1d is the formula for finding the nth term of a linear sequence. But if the number of terms is not known, we can also find the number of terms when the last term is also known. So take note so that you understand how and when to use each of the formulas. Now we are through with the nth term of the linear sequence. You will solve a lot of questions so you understand what we are explaining here. I advise that you take the video back, you reverse the video, you go back so that you can understand what I'm explaining before you move. That's why I advise you to get your own book, your pen, maybe your calculator that will help you so that you can follow what I am doing. Now, we are looking at the sum of a linear sequence. We are looking at the sum of a linear sequence. The sum of a linear sequence. And the sum of a linear sequence is given by, you have Sn equals n over 2, then you have 2a plus n minus 1 times d. Now this is the formula for finding the sum of the n terms of a linear sequence. Still we are under linear sequence. That's what we are considering for now. So Sn equals n over 2, 2a plus n minus 1 times d. Now you know that n is the number of terms. So n is the number of terms. You know already. A is our first term. Then our d is the common difference. D is the common difference. And what do you use this formula for? Let's take a question so that you understand how to apply this formula. Let's assume that we have to find the sum of the first 5 terms of the sequence. The sum of the first 5 terms of the sequence 2, 4, 6, 8. This is the sequence we are given, and this is an infinite sequence because the last term is not known. Now we have to find the sum of the first 5 terms. So the sequence now solution. The sequence is 2, 4, 6, 8. So you know that your first term is 2. Your common difference, that is 4 minus 2, is 2. We have to find the sum of the first 5 terms. The sum of the first 5 terms. So for n is equal to 5. And so H5 from the formula is Sn equals n over 2. You have 2a plus n minus 1 times d. Okay, so S5 will be equal to 5 over 2, then 2 times a, and a is 2. So you have 2 times 2 plus n minus 1, and n is 5. So you have 5 minus 1 times d. The d is the common difference, and the common difference gives us 2. Okay, so S5 will be 5 over 2. 2 times 2 gives us 4. 5 minus 1 is 4. 4 times 2 gives us 8. And S5 will be equal to 5 over 2. 4 plus 8 will give us 12. Now, 2 goes into 12 6 times. And 6 times 5 will give us 30. So, the sum of the first 5 terms of this sequence is equal to 30. Now, let me show you what is really happening. The first term is 2. Second term is 4. Third term is 6. Then we have the fourth term is 8. So, if you want to find the fifth term, it will be plus 2 because the common difference is 2. So, when you add 2, you are getting 10. So, these are 1, 2, 3, 4, 5. That is the first 5 terms. Now, 2 plus 4 will give you 6. 6 plus 6 will give you 12. And 12 plus 8 will give you 20. 20 plus 10 will give you 30. That is what you are talking about. That is the sum. That is the sum. So this is how we find the sum of a linear sequence. So S5 equals 30. And that is what we use the formula for. So the sum of the n terms is equal to n over 2, 2a plus n minus 1d. N is the number of terms. A is the first term, and D is the common difference. And so that will be all for now on this particular episode. Thank you.